China's rise into a space superpower wasn't loud, it wasn't flashy, and for decades, the world didn't take it seriously. But today, as China prepares bold lunar missions, tests reusable rockets, expands its space station, and challenges NASA and SpaceX directly, one truth has become impossible to ignore. China's space program is no longer catching up. It is accelerating. And the story of how they got here, from their humble beginnings in the 1950s to the world-shaking missions of 2025, is unlike anything the world expected. This is the complete history of China's space program, and the moment everything changed. It begins in the aftermath of the Korean War, during a time when China was still recovering from decades of turmoil. In the mid-1950s, the country barely had the industrial backbone to build its own aircraft, let alone rockets. Yet even then, Chinese leaders understood one thing. True national power required mastery of the skies, and ultimately, the stars. And then came one man who would rewrite China's destiny in space. Chen Shuisen. Chen had been one of America's most brilliant aerospace scientists. He studied at Caltech, worked alongside the founders of NASA's Jet Propulsion Laboratory, and was considered one of the most advanced rocket engineers in the United States. But during the Red Scare, he was accused, falsely, of communist sympathy. After 5 years of political targeting, the U.S. deported him. That single decision changed the course of global space history. When Chen returned to China, he immediately began designing the rockets that would become the foundation of China's entire space program. Under his leadership, China launched its first missile, its first sounding rocket, and by 1970, its first satellite. Dongfang Hong 1 was small, just 173 kilograms, but its impact was enormous. China became only the fifth nation to place a satellite in orbit. For the first time, China proved it could compete technologically on the world stage. But unlike the United States and the Soviet Union, who raced to the moon, China couldn't afford a high-stakes sprint. Instead, they chose patience, precision, long-term planning. While the superpowers burned billions competing for headlines, China quietly studied every rocket, every mission, every failure, and waited. The 1970s and 80s were slow, cautious decades. China improved its Long March rockets, launched scientific satellites, and strengthened its industrial base. But behind the scenes, a far more ambitious dream was forming. It wasn't until 1992, decades after Apollo, that China revealed its true long-term plan. The government-approved Project 921, a three-phase roadmap that would take China from basic orbital attempts to full human spaceflight, and eventually, the moon. Phase 1. Develop China's first crewed spacecraft. Phase 2. Build and operate a Chinese space station. Phase 3. Prepare for a human landing on the moon. Project 921 had no expiration date, no political deadlines, no finish by November mandates. Western space agencies often feared budget cuts or shifting political priorities. China didn't. China planned for decades. And it worked. In 2003, China launched its first astronaut, Yang Liwei, aboard Shenzhou 5. With that single mission, China became the third nation in history to independently put humans in space. The world took notice. But what came next made it clear that China wasn't just dabbling in spaceflight. They were building something permanent. Over the next decade, China mastered orbital docking, long-duration missions, multi-crew flights, and spacewalks. Missions like Shenzhou 7, Shenzhou 9, and Shenzhou 10 refined the systems that would become core to China's long-term operations. Tiangong 1 and Tiangong 2, small temporary space labs, served as China's orbital classrooms. They tested life support systems, docking procedures, and crewed operations. They were prototypes for something much bigger, something China had quietly been preparing for years. In 2021, that moment arrived. China launched the Tianhe core module, the heart of its new permanent space station, Tiangong. Tiangong is sleek, modern, modular, and equipped with robotics, advanced environmental systems, and cutting-edge scientific facilities. While the International Space Station nears the end of its life, Tiangong is just beginning its prime. Inside, taikonauts conduct experiments in medicine, physics, microgravity agriculture, and material science. They test 3D printing, closed-loop oxygen systems, and new radiation shielding, all essential technologies for travel beyond Earth orbit. Tiangong isn't just a space station. It's a rehearsal, a training ground for the skills China needs to build bases, survive on the moon, and eventually push outward into deep space. But even this impressive achievement is just one part of China's space strategy. Because while Tiangong secured China's presence in Earth orbit, a far more daring plan was unfolding millions of miles away: the conquest of the moon. China's lunar program, built around the Chang'e missions, evolved with laser-like precision. Chang'e 1 and 2 mapped the moon. Chang'e 3 performed a delicate soft landing. But in 2019, Chang'e 4 became the first spacecraft in human history to land on the far side of the moon. A region so difficult to reach, it requires a dedicated communications relay satellite. No nation had ever accomplished this. In 2020, Chang'e 5 returned over 1.7 kilograms of lunar samples, the first sample return mission since the 1970s. China became the third nation in history to bring moon material back to Earth, and the only one to do it in 45 years. Then China attempted something even more ambitious. Chang'e 6, a mission designed to land on the far side, drill, scoop, and return samples from a region permanently hidden from Earth. A mission that even NASA hasn't achieved. China succeeded again, and that brings us to 2025, and the most advanced robotic lunar mission China has ever attempted, Chang'e 7. Chang'e 7 includes a lander, a rover, an orbiter, and something truly special: a miniature hopper designed to leap into the moon's permanently shadowed craters. These craters have never seen sunlight in billions of years and may contain vast reserves of frozen water ice. If China confirms these deposits, if they prove the existence of accessible lunar water, then the moon becomes not just a destination, but a base of operations. Water means life support. Water means fuel. Water means China could build a permanent lunar presence. This is why China is moving so quickly. Their next-generation rocket, Long March 10, is being prepared for its maiden flight. Their lunar lander is undergoing engine and structure tests. Their new lunar spacesuits, revealed in 2024, are already being refined. China is not preparing for a symbolic landing. They're preparing for a program designed to stay. And they are not doing it alone. China and Russia have formalized plans for the International Lunar Research Station, a long-term base on the moon's south pole. Multiple nations across Africa, Asia, Europe, and South America have expressed interest in joining. For the first time in decades, humanity isn't heading toward one moon base, but two competing ones. Meanwhile, another race is happening back on Earth. A race China once lagged in, but now threatens to dominate. The race for reusable rockets. For years, China appeared far behind SpaceX. Falcon 9 was landing booster after booster, while China's rockets still fell into the ocean. But around 2021 to 2023, private Chinese companies began emerging with startling speed. Landspace, iSpace, Galactic Energy, Deep Blue Aerospace. These companies began testing methane engines, stainless steel stages, and vertical landing prototypes. Some succeeded, some failed, but each success accelerated China's progress in ways the world wasn't prepared for. Landspace's Zhuke 3, a massive stainless steel reusable rocket, now stands as one of the most promising non-SpaceX reusable launch vehicles on Earth. China's state-owned space agency redesigned the Long March 9, originally a traditional heavy rocket, into a fully reusable Starship-style stainless steel giant. China is aiming for rapid reflight, the same key metric that made SpaceX the world's most dominant launch provider. The gap is closing, but the moon isn't the only frontier China is expanding into. In 2021, China landed the Zhurong rover on Mars, making China the second nation in history to successfully land and operate a rover on the Red Planet. Their next mission, Tianwen 3, aims to return samples from Mars, potentially beating NASA, whose own sample return program has suffered funding delays and redesigns. Beyond Mars, China's Tiangong-4 mission will fly to Jupiter, with a secondary probe continuing toward Uranus, an outer planet the United States hasn't visited since the 1980s. China is even testing nuclear propulsion, nuclear power systems for deep space, and orbital fuel depots, technologies that could shorten travel times and support bases far from Earth. But perhaps the most surprising frontier is something straight out of science fiction: space-based solar power. China has already built and tested a prototype capable of beaming energy wirelessly and plans to launch larger versions in the late 2020s. If successful, China could create the world's first orbital power grid, delivering clean energy from space to Earth. Meanwhile, in orbit, China is deploying satellites equipped with robotic arms, maneuvering capabilities, and close proximity operations, technologies that can service satellites or disable them. The United States has repeatedly warned that China is expanding its presence in cislunar space, the region between Earth and the Moon, a strategic domain no country has ever attempted to dominate. All these advancements point to one unavoidable truth: China is no longer a follower, it is a competitor, a rapidly rising space superpower intent on reshaping humanity's presence beyond Earth. And now, NASA, SpaceX, and governments worldwide are racing to respond. The next decade will determine more than just who lands on the moon first. It will determine who builds the first lunar base, who controls cislunar space, who reaches Mars, who defines the rules of deep space, and who leads humanity into the solar system. China's journey from a struggling nation to a modern space giant is one of the most dramatic technological rises of the century. The decisions made in the 1950s ripple across the 2020s. The rocket designs from Qian Xuesen's notebooks echo in Long March engines today. And the quiet choices China made decades ago have led them to the center of the most important competition humanity has seen since the dawn of the space age. Because today, for the first time since Apollo, the world is witnessing a real space race. Not between the United States and the Soviet Union, but between NASA, SpaceX, and China. And the next chapter? That might just change everything.